part of really implementing this idea. Okay, we discussed that, okay, these parts are connected with these frequencies, and there are engagement of, let's say, frontoparietal areas, and attention is important for, let's say, controlling craving or controlling our thoughts or controlling the emotions that we have. Is there any chance that we can use technologies to use our understanding about these kind of connectivities and connections that we have in the brain in terms of doing interventions with external oscillatory technologies? And the idea of, let's say, kind of targeting these areas. But the challenge would start from this point in terms of, even with simple, let's say, atlases, you can see that it's really hard to clearly define, okay, what are the parts that are involved in attention. As you can see here, even people would start to name other, let's say, parts of the brain involved in attention, something like dorsal attention network, ventral attention network, frontoparietal part. So there is no real good, let's say, target right now to see what will the pieces that we are going to target. And it is not really clear which part is going to be the ideal target in the group level and then in the individual level, and how we might be able to do frontoparietal synchronization. And the simple idea is, okay, we have the frontal part, we have the parietal part, we put the electrodes and do the stimulation. But we realize over time that it is not as simple as it is, as you can imagine. Even within these, let's say, frontoparietal parts, there are different parcels. It is not just, let's say, one single DLPFC, one single parietal cortex. That would be easy to just connect these pieces together. I mean, these parcels would have different types of behavior as well. And there is an atlas within the Yeo kind of group that they try to even differentiate these pieces. So things would get a little bit more complex when we try to use these technologies. It's not as simple as it seems in the first place. I'm just going to give you an example of what we are already doing in terms of, these are the analyses that we have done last week. It is basically fresh out of oven type of analysis that we are doing right now. And this is the first time around the world that somebody is doing this analysis in terms of targeting. If we are going to target frontoparietal connectivity, what part of the brain is exactly involved in that, let's say, frontoparietal connectivity, and how we can kind of engage them and how we can measure this engagement. This analysis has been done by Ghazale, one of my PhD students, one of the brightest PhD students I've ever had. I'm not sure Ghazale is online today or not, but I mean, she has done a really nice job kind of discussing about, okay, if we target frontal part, and this is the major part that we are stimulating in the frontal part, what parts of the brain would be connected to this frontal part while people are seeing drug cues. So we want to have craving-related connectivity. So we use what we call task-based connectivity, or what we call PPI, psychophysiological inventory. There's a specific kind of type of connectivity analysis within a task. So we want areas that are connected to this frontal part while they are seeing drug-related cues. So there are connections. So when they see the drug cues, these connections would be specific to drug-related cues and craving. As you can see here, we found the active cluster here within, as you can see here, the parietal part. So that is good. So this is, I mean, basically, when we put the electrodes on the right side, the target on the right side, this is the only part of the brain that would have significant task-based connectivity to that part. And now we need to think about, okay, how to target that, a specific area in the brain. We put them in, let's say, an atlas, a surface-based atlas. This part is here. As you can see here, compared to some of the activation that we had before that was around here, this one is lower. And we realized that if we want to target this area, we need to put the electrode on CP6 and CP5. Before, we have been targeting here, which was P4. And there was, I mean, the effect was really poor. So we have been just getting frustrated because we have been stimulating the frontoparietal part without any response, but we realize that it is not basically this part of the parietal. This is a lower part of the parietal, that now we can put the electrode in this part and start to stimulate. So this one and this one. So you can see they are different. So this is the previous montage. This is the new montage that now we are targeting. So you can see that even minor details could be critically important. And this is a new finding. We have not published that. We are kind of working on the writing the paper for that, and I'm hopeful to be able to share that with this. And Andy, I'm really excited to have your thoughts about that. I'm definitely would be interested to send you the ideas. I mean, you are a shining star in the field of kind of head modeling, so we can discuss about that in terms of how we can optimize that. These are basically, I mean, really fresh out of the oven in terms of kind of we have done the analysis just the last few days. So we are trying to complete that. And the idea that we have right now in terms of using the frontoparietal synchronization and targeting executive control network, and within the executive control network, defining a specific neural target measure, how we are measuring the connectivity between these areas, neural target measure. And then we are hopeful if we change this connectivity, this target would be related to craving or performance of these people. And then finally, this target engagement through the changing in drug craving would change their drug use behavior as well. So this is the pipeline that we are writing now, a paper about that with Ghazale, in terms of how functional neuroimaging could inform intervention development. And as you can see here, we are on the other extreme side of, let's say, mindfulness-based meditation. So we have cognitive intervention on the other side. Now we are discussing about, let's say, neural technology intervention to engage the cognitive networks and the cognitive processes that are involved in attention. And the idea that we have right now is we have been doing the stimulation inside the scanner and combining that with what we call neurofeedback in terms of recording what is happening and then giving subject a feedback and then recording again, trying to improve the connectivity. We are combining them together that we call TS fMRI neurofeedback. So we do the stimulation. If I go back to this figure that I showed you before, the idea is we have low frequency stimulation to engage these connections from 3 hertz to 13 hertz. But which frequency is going to work for Hamed? Which frequency is going to work for Andy? Which frequency is going to work for Puriya? And that is kind of the personalized frequency is a big question. Which of these frequencies is the optimum frequency for people? So what we do basically in the new development, we explore different frequencies in terms of the stimulation. Let's say we start with, let's say, 8 hertz, do the kind of recording, have we engaged the target or not? We change that 8 to 10, from 10 to 12. So trying to find which frequency is going to work. And it's something like a closed loop control system, trying to find the optimization process. And that is the kind of new wing that we added in terms of improving neural target engagement with optimization, individualized optimization system that we are developing right now. Okay, that was the end of the session today. It was a long session, but I hope that you have a sense about, first of all, what do we mean by attention? And attention would engage different levels of cognitive functions. It's not just one network or one specific activation. There could be different contrasts. And there could be different interventions for attention engagement, and there could be different neural technologies that could help us to improve attentional processing. And all these things could come together in the context of applied cognitive neuroscience that I love, and I highly encourage you to follow this field because of lots of excitements. And meanwhile, I should say there are many frustrations as well in terms of finding the right kind of target. But if we can find something that is going to be really exciting and it's going to be really interesting to do. It was great to have you today here. I hope that you will kind of have a super nice week. Looking forward to see you next week.